This is an FWPA project that has been led by Lincoln Agritech Limited in New Zealand. And I guess the basis of it was to do an industry scan of innovations that may across the whole span of forest operations that could have some interest or potential for application in different parts of Australian forestry operations. So there was a few different think tank meetings initially to gather a few ideas, and then a working group sort of shortlisted some of them, and then Alistair and team did a deep dive into those and have presented a user-friendly wiki, I think you call it. That's a new term for me, which will sort of enable people to sort of get in there and search through it and have a closer look at all the various links in the technologies that have been, I guess, the whole broad scope of technologies that have been uncovered or discovered, as well as there's an accompanying report, which I guess will be put out on the FWPA website in the not too distant future, shortlist going through the process and then shortlisting some of the ones that I guess you'll be no doubt showcasing in your presentation today. So it's been a pretty short, sharp, but I think worthwhile project. This is not while the formal project itself is coming to an end, the intent is for this wiki to be a bit of a live thing that people can sort of add to, comment on, test ideas, put their 2 bobs worth in on whether it did or didn't work in their situation, so that we can all learn from it. So without further ado, I think you can probably make a start, Alistair, and we'll just keep on letting people in. I think I invited everyone who's anyone in HQ Plantation, so there's a lot of familiar faces on the road, but we'll try not to dominate things too much. Thanks.
Great. Thanks, Ian. Can you see my presentation all right now?
Yeah, fire away.
Yep. So just a note that we will be recording this session and we'll make it available online later. And also, if you have any questions, could you please put them in the chat function? And even if we don't get a chance to answer them during the session, I'll answer them later. So if you just put any questions in the talk box, the chat box there. Yep. So thanks, Ian. Thanks for the introduction. This is the final webinar for the project, Discovering Global Automation and Robotics Relevant to Australia's Forestry Needs. And I think one of the key things about this project is the fact that it's an industry-led technology scan, and that's been a really important part of the project as we've gone through. The number of project objectives, probably the first and one of the most important ones, was to identify an advisory group from the Australian forestry industry. And that was really important because it provided great guidance as we went through the project to which of the technology areas were relevant. We then undertook effectively a global technology scan, looking at forest robotics and technology innovations, and then went back out to industry with a discussion to identify which of these areas of technology were of interest to the Australian forestry industry. Once we'd identified that short list of areas, we began preparing in-depth profiles of the relevant tools and technologies, and then going through the process now of disseminating and discussing these project results. And we've launched the Australian Forestry Robotics Wiki page that I'll talk about a bit later on. The key benefits the Australian forestry industry desired from the tools and technologies that we were looking for are here: increased productivity, develop innovative work methods, address labour shortages or labour supply challenges, enhancing safety, reducing environmental damage, attracting new talent to the industry, and investigating how robotics can help minimize fire risk through managing fire fuels. And I think it's also important to note that most of those challenges are the same for most primary industries in New Zealand and I suspect Australia. So they're not unique to the Australian forestry industry. primary industries are dealing with this around the place. The aim is that the findings of this work will help the Australian forestry industry prioritise relevant adaptation and research and development in automation and robotics, effectively give a lead on where the R&D funds should be spent, build industry skills and understanding in these areas, and begin integrating robotics into forestry management practices. The methodology: we set up the steering group, we carried out a comprehensive technology review, which ultimately ended up with a long list of over 300 tools and technologies. We identified the focus areas, we undertook detailed technology profiles, and then we shared these with the project steering group and fine-tuned them to the final publication, the final report. And all of the tools and technologies are available in our wiki, in the wiki, forestry wiki page. Okay, if we look at the long list and the short list of topics, just as an example, our long list was effectively a giant Excel spreadsheet that I remember sometime last year starting with about 20 lines, and it ended up with 300 or more lines. And we looked at technologies and tools, and we broke them down into different areas, and then we looked at whether we thought they had particular application or not. And these went backwards and forwards with the project steering group to help us shortlist the tools and technologies of interest. The advisory group feedback was really important, because we decided that the advisory group decided relatively early to exclude technologies that monitored forestry and inventory, and that was a big help, because the feeling was that the industry was well across those technologies, and the focus was on robotics and automation technologies that will increase productivity, reduce risk to the plantations and nurseries assets, and also to the humans involved, and also substitute the humans involved or assist humans involved in plantation, nursery management, harvesting tasks. So still quite a wide scope, but it had narrowed it down considerably and gave us the ability to sort of focus in a bit more there. And what that then gave us February this year was, I think we said in the project we'd look at 3 or 4, and it sort of grew, but we ended up looking at these topic areas: augmented reality, automated battery switching and electrified transport for logs, autonomous planting, digital twin systems, exoskeletons for workers, fire control systems based around UAVs, operator assistance, and we broke that down into 2 parts. One was operator assistance that came from the original equipment manufacturer, and operator assistance that was emerging technology, and we recommended stay informed on where it's going. And truck platooning and transport operations, nursery technologies, and then remote controlled filling wedges. So we'll go through these now, and I'll give some details on the areas, the technologies in particular that we looked at, and some general overviews of what we found. If we start with augmented reality, effectively, augmented reality is when there is digital forestry data that has been gathered that is then overlaid with operators in the field. And so this could either be in a machine where the digital data is showing up on a screen in the machine, or possibly in augmented reality glasses or headsets. And the ability this has is it can assist with planting, thinning, pruning, and training support. Certainly opportunities there for hazard identification and making workers more aware of hazards there. And the aim is greater efficiency, safety, and precision. So we investigated the possible role of augmented reality in these areas. And we found that there's a number of works looking at augmented reality and machinery operation, and these will be explored when we talk about operator assistance. So they are already in the machines and they're being supplied by some of the equipment manufacturers. But if we exclude those, there were effectively only two works that we thought were relevant. One was a European project looking at bringing digital data and reality together, augmented reality and forestry, and another a paper out of Germany, stakeholders' perspectives on optimizing forest management through augmented reality. So these specifically aren't technologies, but they provide a good background and scene set for where technologies may be relevant. For with the European project, it's really only halfway through. The end of the project's in 2028, and so that's a European project exploring how augmented reality can improve digital data and field operations. It still says that the challenges that I think have been widespread with augmented reality around GPS accuracy and connectivity, they're still having those issues there. And I think it's also important to note that the greatest benefits from something like augmented reality is when it's combined with digital twins that we'll talk about, operator assist systems, and also possible future automation technologies. So what we're saying there is at this stage, that project doesn't offer specific benefits for the Australian forestry industry, but I think it's worth keeping a watching brief on that project in Europe as it comes to a conclusion there. The other paper is this paper out of Germany, particularly by the University of Freiburg, and they're looking at real-time forestry data and having augmented reality headsets, helmets, glasses, etc., to provide workers with better decision making, safety, etc. And they are working in the other project, the project that I've just outlined there. So I think the two are very aligned, but they are making good steps in this. But it's still very much at the beta testing stage. But I think, again, it's worth staying aware of where these projects go in the next couple of years. And that just gives a brief outline on what they're doing in their project. So I guess the key thing, the summary with augmented reality is the key applications are around guidance for workers, whether it either be on foot or in machines, around thinning support, harvest support, hazard visualization. While its AR hardware is commercially available, it's still only in pilot stages as far as forestry sector goes. And there are all the major challenges as far as GPS signal, connectivity, etc., that happen in remote workplace. I think, as I said before, augmented reality is best viewed as an enabling technology, and if it is to progress, it will progress in conjunction with things such as digital twins and data-rich environments to provide benefits in the forest. There is also a number of machinery operators working in this field, and so certainly staying aware of the machinery operators and how they develop this area will be important, and I'll talk about that further when we talk about operator assistance. Automated battery switching, this was an area new to me. The concept there is that trucks have an electric motor and they have a large battery in them, and when that battery needs recharging, rather than the truck having to wait while that battery is recharged, the battery is switched out for another battery that is already charged. So it's less downtime for the truck and less reliance on charging infrastructure around the place. Obviously, it's better suited to environments where there are known transport routes, because you need a hub for changing batteries. And so it's it may be suitable for things like timber mills, etc., where there is a large power infrastructure and the potential infrastructure for swapping out batteries, etc. Oops. In this area, there's a number of suppliers, and it's a rapidly advancing area. Even in the time from when we started looking at this late last year to May, there were major advancements in this field. And it's important to note that the first three there are battery swap systems, but the bottom two are not battery swap systems. But I think they're interesting ideas in this area as far as electrified transport goes. So Janus Electric have developed a battery swap solution for heavy forestry transport. They convert diesel trucks to electric, and they can swap the battery out in 5 minutes. Some of you will already be aware that there's been a trial undertaken down in the Green Triangle looking at a converted logging truck. The trial, it says, demonstrated strong performance, reliability, and rapid battery swaps. But I think the key thing there is the technology proved feasible, but requires economic and policy support for wider adoption. So it needs to have a greater infrastructure to really work. And I think the important thing to note is that the company involved isn't currently running that truck. So I think that probably speaks volumes. Battery as a service. So in this situation, the operator owns the truck, but doesn't necessarily own the battery. So the battery is being used as a provider of energy, and the cost of the battery, the cost of the charging infrastructure, is not borne by the transport operator. And that allows battery technologies to be upgraded and maintained more quickly than if they were owned by the transport operation. CATL is a company out of China, and they've developed a large-scale battery swapping ecosystem in China, but it's not very advanced in Australia. But it may come into Australia, and I think it's worth being aware of that. Caterpillar is probably the model that's most known in Australia. So Caterpillar is currently working with electrified heavy haul trucks in the mines in Western Australia, where they are swapping batteries out from these heavy haul machineries. They have no interest in forestry at this stage, but given they are in Australia, they certainly could be interested in having that conversation. So this is not a battery swapping technology, but this is a European project where they're looking at trying to accelerate the transition to electric trucks by addressing the challenges with infrastructure, etc. Their goal is to achieve 50% electrification of new forestry trucks by 2030, and they've shown that these battery electric trucks can operate reliably year-round, including in their very cold environments. The main barriers they found are not the vehicle technology, but the infrastructure, the access to the grid, and the commercial models. And I think this is a theme that you'll see going through this work, is often the technology is available, but the infrastructure to support and have the successful rollout of the technology is the challenge. So yeah, that's just a bit more about the tree project, transition to efficient electrified forestry transport. And the core aim is to look at removing those system level barriers with the infrastructure, etc. Another system that I think is probably worth staying aware of is the Scania megawatt charging system. So in this environment, they're creating an ultra fast charging for trucks, and the concept is that these will be ultra fast charging hubs at key points, and again, a timber mill may be a key point where the truck could be charged from 20% battery capacity to 80% in less than 30 minutes. So potentially, while after the truck is unloaded or while it's waiting to unload, it could be recharged up, and this could be feasible given the timeframes involved. I just put this table, and we won't go over it in detail, but if people want to look at it, it's either here or it's in the report, and that's comparing the different electrification pathways and how the benefits of the different pathways there. If we look at the next topic is autonomous planting. If we look at that, it's rapidly advancing, the area of autonomous planting, but they remains at an early stage. The challenges include technology readiness, reliability, cost, and scalability. One of the key things identified is how some of the European systems require significant adaptation to be suitable in Australian conditions and also New Zealand conditions. And also that mechanisation of planting systems can be a key stepping stone to full autonomy. So we'll see that the adoption of these things will occur gradually as operator assist, and it will also align with data-driven forestry. So the autonomous planting will then allow the location of specific plants to be recorded accurately. That will then enable weeding technologies, etc., to come in over later on. Now, Mike Sutton's carried, I don't know if Mike's on the call at the moment, but Mike Sutton's carried out a commercial scan of mechanised planting that's available through that project code there. And so we haven't looked at all the commercial solutions available. We've looked at some of the new and upcoming autonomous planting systems. So as I say, there are some commercially available systems from Brack Forest and Plant Forestry that no doubt people have been aware of, but we're interested in, so we've looked at three. One's the Sodra Brasat, the auto plant system out of Skogforsk, and also just put in a patent that I thought was interesting and provided an interesting sort of case study, really. So the Sodra Brasat that I think people have probably seen in magazines, it's an all-in-one autonomous planting robot. It identifies planting locations, prepares the site, plants the seedling, records the site or location. It demonstrates the future potential of data-driven autonomous planting. But anybody who's been in a real-world forest situation can look at that and say that that's unlikely to be successful in most replant situations. And therefore, it's important, I think, to look at these things as a reference and a potential future concept rather than something that's ready to deploy. And some of the technologies on here will be relevant, but the system as a whole is probably not relevant unless there's a new planting site. Skogforsk, which is a Scandinavian company, is undertaking a lot of technology projects, and one of the projects they're looking at is this Autoplant, a fully autonomous forestry planting system. And just to show, I'll show you, the diagram here. So effectively what they're trying to do is create a situation where a machine goes out there through different sensors, identifies the environment that it's planting into, locates an area to plant, plants the plant there, records that. So effectively it's got this totally autonomous system with a number of sensors in there. Again, this is at a very preliminary stage, but the technologies that are coming through here no doubt will develop rapidly and may become available in machines closer to market. And if we look at this patent here, someone put in a patent for a system that plants nursery seedlings out in the field, and you can see that the image of it down there. It looks like something suitable for a vegetable crop rather than a tree crop. But what it does show is some of the sensor systems, some of the cassette planting systems, etc., that can be used. And so I think it's important to stay aware of these technologies, because while that is unlikely to appear in the field, some of the technology, some of the algorithms, the sensors, etc., that are discovered as part of these projects could become applicable for machines that actually could be of value in the field. I guess one of the questions that the steering group has asked during this process is, what is needed for these automated planters to succeed in Australia? One of the key things is that automated planting will have to be the end point of an integrated system that starts at the nursery. Plants will have to be produced to a particular spec that can then suit the autonomous planter. So the plants will have to be of a certain size, they'll have to be contained in a certain way that they can then fit into that autonomous planting. So the planting will be the end point of a system that goes through the nursery and into logistics, and then that will feed into field operations. Success depends on consistent site preparation and suitable planting sites. I think that's probably the major one there. Is anywhere that there's a replant being undertaken, the environment is very challenging, and I'm yet to see something that overcomes that. Equipment must be adapted to Australian species, soils, residues, and terrain, especially the difference between conifers and eucalypts. Sensing systems and AI will require training with Australian data sets. Multi-season trials will be needed to prove reliability and build confidence. The contract and risk sharing models will support technology adoption. That's a really important one too, is that many of these technologies are very expensive, and for one operator in Australia or New Zealand to buy these and put them in their system and make them work is a massive commitment, both of capital and time and effort to get it working. So the opportunity may be for the industry as a group to look at how they could support technologies coming in for the industry as a whole or a group of companies, rather than only one specific company. Again, won't go through this table in detail, but people can refer to it. And this is looking at the European tree planting systems and what some of their limitations are, and what could be addressed to overcome those limitations. I think another thing that's probably worth noting is since the report was published in May, Ponce has just released this buffalo planter concept, which is using one of their forwarder platforms and putting in place a planting tool base on it. It's a bit of a thunderbird for forestry trees. I haven't evaluated this in depth, but I think it's worth keeping an eye on this, because obviously they have very good proven track record in the forestry technology space. Okay, digital twins. Digital twins create a virtual data-driven model of forests and operations. So effectively, a whole lot of data is recorded for a forest, and the data recorded for that forest allows a digital twin, being a three-dimensional model of the forest, to be created, that then has all the spatial information, but it also has growth models, production models, etc. in there. The value of this is that it allows people to undertake what-if scenario analysis. So what if if you want to harvest trees of a certain size, how would that work? Can you plan your harvest routes there? Can you plan your transportation of logs out of there? And also looking at fire risks, etc. Most forestry digital twins, and I think most primary industry digital twins, are at pilot to early operational stages. Implementation costs are high, and a lot of people are putting a lot of time and effort into trying getting these digital twins to work. I think the key thing there that I've highlighted is the success will depend on the data quality and the government's and the organizational adoption. So a digital twin to be successful needs to have high quality data and the ability to look at it across the full range of operations in the organization. And that's just I just referenced that because it's a good image showing the concept of digital twins, and the paper there is a very good paper outlining the background to digital twins and some of the practical implications of digital twins in agriculture and bioagriculture. Forestry is included there. Effectively, there are a number of technologies that claim to be digital twins that aren't digital twins. And I think anybody who went to the forestry conference in Adelaide last year would have seen a number of presentations about digital twins, but what most of them were models rather than a true digital twin. This REMsoft anchored digital twin has linkages between inventory, growth models, harvesting, scheduling, etc. So it has a combination of different models, etc., that produce a true digital twin model, digital twin environment. And it can give the opportunity to improve decisions. But I think the question has to be asked of digital twins is how much investment of time is required to create the value from digital twins for any specific company. And yet there is a commercial tool out there, FWPA Smart Forestry, that has got a number of tools within its platform that allow you to model inventory, look at scenario modeling, and also operational tools in a mature platform for forest planning and management. So this is one that can be bought off the shelf for a digital forestry system, and the benefits are already being shown. But again, I think you have to ask how much time is a company willing to invest in order to get the benefits offered by the digital twin. Okay, sort of change tacks here, come to a more practical human level. We looked at exoskeletons. The aim of exoskeletons there is to reduce fatigue and injury in manual forestry tasks. Obviously, anything to do with primary industry can be highly repetitive, and we identified that effectively there are two parts to the forestry workplace. One is in the nursery, dealing with trays of trees, and the other one is in the forest around silvicultural activities there. We think that passive exoskeletons are probably best suited to forestry. So the two types of exoskeletons, one is powered exoskeletons that have a battery in them and have motors. And so effectively, as you walk or as you move your arms, there's motors supporting your activity. But passive exoskeletons are effectively storing energy as you move, and then using that energy to support you on a task. So if you bend over, a passive exoskeleton may have a spring or flexible component in it that stores that energy and then assists you in standing up. And we think those are probably more applicable, particularly in the forest, because they don't rely on batteries, etc. And I think, they're definitely practical technologies that they're being used in other environments. So it seems only logical that they could be used in a forestry environment. Yeah, as I said, that. Okay, if we look at, there's a whole range of exoskeletons available out there, and this one, Skelex 360, is considered to be one of the more robust and best suited for forest operations. There's up to 10,000 in use globally, so they're relatively widely used, and they're less than $10,000, so they're not extremely expensive. And because they're a passive system, they don't have any reliability on electric. And the trade-off is they're slightly higher cost, but I think, $10,000, that's sort of acceptable. Autobock is a German company that bought technology from another company that widely adopted. They work in different environments, and they're considered a good use for planting, bending, moderate lifting, etc. But they don't have shoulder assistance, and they have less twisting support than the Skelex. Oops. And this is interesting. So the Spanset Delta suit is currently being evaluated in Australia, I think. Ian, that's the plan. And so looking forward to seeing feedback from this, how it supports, how workers find it in the field. Because using one of these exoskeletons, walking or moving in an open environment is very different to a forestry environment where there's branches, things to get hung up on, catching fittings, etc. So it's really important to see how these go in the field. I think another thing too that's really important to keep a watching brief on is the New Zealand Forest Growers Research Organisation is beginning to undertake a global review of exoskeletons in conjunction with the old SCION, the Bioeconomy Institute Human Factors team here, to undertake a high quality global review of exoskeleton technology. So they plan to undertake this by 2026. And my understanding is that the results will be shared with FWP Australia. So that will provide a very valuable resource there. Okay, fire control by UAV. We talked, there are a huge amount of technologies around fire identification and fire control. And I, lucky enough to go on the post-conference tour of the Green Triangle and see one of the brand new fire sensing towers set up down there. But the project group determined that we focus on looking at fire control by UAV, so looked at that area there. And the aim was to look at fire control after detection, not look at the detection mechanisms. So we investigated that, and there's obviously pieces of work being undertaken in Australia already by the ANU and Western Sydney University. They're looking at it. The greatest value appears to come when UAVs are considered as a part of the sensing system and then the early control system rather than just the UAV by itself. So obviously the concept there is that there's an early detection of fire sites, a targeted response, and trying to suppress that fire before it becomes large, at which point UAVs are probably not such a practical operation. And the autonomous fire suppression is a longer term option, complete option there. So effectively, there's two types of UAV systems. One is the ultra early detection system, where the UAV system detects the fires and then suppresses the fire while it's a very small site. And the two we selected there are a system out of Germany, Dryad system, and Ponderosa out of the USA. And the other system is where UAVs are used to target hotspots at the tail end of a fire, looking at cleaning up the remnants of a fire there. So quite different case studies, applications there. So the Dryad fire system uses sensors in the trees and in the forests and solar powered drone hubs. So it's quite a advanced system, and it's being rolled out in Europe. Its key advantage is its rapid response, is its ability to identify fires when they're small and control them before they grow. But whether the widespread adoption proves successful, time will tell. But I think it's definitely worth keeping an eye on there. So the system there has these sensors in the trees. The sensors then effectively identify where the fire is, feed this information to these UAV hubs that are solar powered, and the UAV can then go off and control the fire through an application of a small amount of liquid or fire suppressant. It's quite space age sort of stuff. And it's advancing rapidly. So it'd be interesting to keep aware of this type of technology and whether it might be applicable for a scale of forestry as is present in Australia or New Zealand. A similar system is a Ponderosa system, where they have autonomous UAVs that attack wildfires when they're small. So it's the idea is that very similar, detects fires when they're small, goes out and controls them, particularly in the areas where there's forest and urban interfaces, to try and stop fires spreading into urban areas. And it still requires human authorization there, so it's not fully autonomous yet. DJI, who are the biggest company of UAVs in the world, are obviously in this area. They have a number of deliverables: hotspot detection, thermal imaging, etc. And their technology is highly mature. They have a lot of applications that seem to be growing in capacity of lifting capacity of liquids, spreading fertilizers, etc. there. And they have a ecosystem that that has the analysis of fires and can identify them in the early stage and then respond rapidly to them. So again, I think these technologies are not at the level where they could be rolled out to the Australian or New Zealand forest situation, but they are developing rapidly and worth staying abreast of. And I think actually just this month, DJI is rolling out new technology and undertaking field demonstrations. So worth staying aware of those. And another system is this Walkera system, similar to the UAV, to the DJI UAV system though. And the thought is that this sits between monitoring drones and firefighting aircraft. So you've got a large, strong UAV that can carry fire suppressant and liquid to control fires while they're small or undertake mop-up activities, rather than having an aircraft out there. Other technologies we considered there are a number of tracked remote controlled firefighting platforms, and in the image there is one called Majerus Fireball. These are effectively fly-by-wire machines where there's an operator operating them from a distance, and they go out into the field and they spray water and they clear paths, etc. The thoughts were that they would be less valuable to large-scale Australian bushfires, but could be useful in particular areas. The cost was around $1 million Australian each, so they're certainly not substantial cost. And the other area that we considered but didn't explore at any great length was autonomous firefighting aircraft. So in this case, this is a Cayman K-Max Titan, which can either be operated with a pilot or autonomously, and that can carry up to 2.7 tons of water. A couple of issues with this. The first one is obviously the cost, $28 million, probably at least, but also the fact that it requires a high level of infrastructure on the ground as far as refilling it goes and what have you. So yeah, certainly top end and may not be particularly valuable. Okay, if we go into operator assistance, so this operator assistance is improving productivity, safety, and well-being for operators, but still the operator maintains the full control of the machine. They can help by enhancing safety, reducing fatigue, and yeah, like I say, reducing operator error, improving productivity and well-being. Another thing that I think is really important is if we think about the autonomous forestry or robotic forestry being the desired endpoint, the operator assistance machinery will provide a stepping stone to that, because as the machines have more technology involved and they can help make decisions, that provides a pathway to autonomy. When we look at this, we split it into two areas. So effectively, there's a number of operator assistance technologies that are already commercially available. And there are some that we looked at that are, I say, recommended, but these are ones that are not commercially available yet, but that we recommend to keep a watching brief on. And effectively, the operator assistance is offered by all the major forestry machine operators, Komatsu, Volvo, Ponce Deere, John Deere Forestry, Caterpillar, Tiger Cat, Rotney. So these have all got offers in the operator assistance where they've got the ability to, they've obviously got GPS technologies in them, they've got cameras mounted on the boom that can help determine trees to harvest. They have the ability to cut trees to length, etc. So they have various things that are already commercially available and offer the benefits to the operator, but also to the efficiency of the operation. And again, a table there that outlines the specifics of the operator assistance from those manufacturers. If we look at the recommended technologies in the operator assistance field, we can see there's a few there. So the Nordic Forestry Automation Program is using a heap of sensors on a machine and then putting these through an AI decision support system that creates a live digital map of the trees. And critically, it's assessing the size of the tree, the location of the tree. They claim that it has accurate positioning under forest canopy, which is really important. And it's providing a map for the operator of the trees to harvest, but also the route to travel in the forest situation there. So this sort of shows that if you look at the image on the right there, they're putting them in harvesting machines where they have the sensors and a computer module, and then the display shows the operator in this example, it's showing them the population that they require for the thinning operation, and they can identify stems that they want to remove to create the desired population there. So that's quite an advanced system that I think certainly worth keeping abreast of. Now, my understanding is there's one of these in Australia, but I haven't been able to find details on how it's performed, so that people within the industry will be aware of this. Another one is Skogforsk, and you'll see this name pop up a lot, is they have avatar operator training, where they have effectively a machine simulator that gives a virtual forest terrain and scenarios to help bring the operator up to speed more quickly than not having that sort of tool. And the claims are that it delivers faster onboarding of new operators, so they can learn in a virtual environment what they will then see in the forest. Obviously, the benefits are that it's a much safer environment for an operator, and also there's no potential product losses by learning on this machine there. And it can be fitted in different harvesters, or set up, sorry, to simulate different harvesters, so operators can learn how to operate different harvesters. Another thing to keep a good eye on is the Forestry Growers New Zealand are carrying out this large project, Forestry Work in the Modern Age, where they're looking at addressing labour shortages, reducing costs and harvesting, improving worker safety. And this is an industry-led R&D program co-funded by government, carrying on at the moment, to be completed in 2027 and possibly beyond. And it's also a substantial project there. And what this is focusing on is these areas: harvesting automation, log identification, debarking, etc. And I say that because they've already had some commercialized technologies come out from this program, and so they're already making early wins. So I think definitely the similarities between the Australian industry and the New Zealand industry are very strong. So certainly keep working with FGR so the two industries can learn and develop together. Oops, wrong way. Another one is another Skogforsk project, and this is Trodson Forestry Teleoperation Lab. And here they have working towards having a fully fly-by-wire system, so an operator physically removed from the harvester or forder can operate it from a remote location. And the idea here is that this increases the potential pool of operators, reduces fatigue due to machinery movements in the field, and also provides a practical way of going from conventional hands-on operation to automation by removing the operator on the machine. It could also be highly relevant for Australian forestry for challenging conditions, steep terrain, workforce shortages, etc. A similar system is this Kodama Autopilot, where it's providing remote operation of forestry machines. Again, it's at a pilot to early commercial stage, but again, it also offers a potential pathway from manual operation to autonomous operation by having the remote operation of these machines. If we summarize the operator assistance area, there's already forestry, as you well know, there's already forestry machines with operator assistance features in them commercially available. They improve operator assistance, productivity, they improve operator safety, productivity, and well-being. and the assistance can include motion assistance, guidance, teleoperation, training, and safety. Many of these systems are mature in the commercial machines and can be deployed incrementally, so that you can use one system and then add on to it in time without incurring a lot of risk. The key things there is that these operator assistance systems provide a bridge to potential future autonomy, and that incremental adoption offers the lowest risk pathway to improve productivity and automation. So rather than a wholesale change of machinery, wholesale change of production systems, adding these technologies onto existing platforms, existing harvesters, existing forwarders is a lower risk and lower cost model. And as I say there, Skogforsk are leading work in this area, and also FGR New Zealand are carrying out good work in this area. Okay, if we look at truck platooning, the concept with truck platooning is that one truck is operated by a driver, and then other trucks follow that driver and follow the route of the driver, but also have sensors on, obviously, to avoid obstacles, pedestrians, etc. It's particularly attractive for something like forestry harvesting, where a block will be traveling the same route to a mill, and it'll basically be repeating that pathway a long time over a number of weeks or months. Yeah, as I show, that just shows that the driver in the first truck leads the trucks, and then the other trucks follow remotely. Looking at it, there's been much talk and limited action. And if we look, when we looked at it, we actually realized that some of the systems that appeared interesting in the transportation area were not actually platooning, but they were still interesting anyway. So the only platooning system that appears to be more than a concept is this FP Innovations Kratos autonomous truck, where they are currently operating two trucks. One truck has an operator, and the second truck is operated as a dummy truck, a platoon truck. And this is being used in Canada to allow one driver to move two loads, but it's not being rolled out commercially, and it's also not operating more than one dummy truck currently. If we look at some other projects that could be of interest in this log transportation area, one is this ETT One More Stack project out of Scandinavia, and this is looking at making all aspects of the log transport from the forest to the mill more efficient by improving the workflows, reducing the time and handling, automating a lot of the activities such as positioning of trucks, when the truck arrives at the mill, just trying to make all those small parts more efficient, rather than having a fully autonomous system. The goal is to reduce setup time, improve productivity, and it's at an early development stage, again worth keeping an eye on, but it should be viewed as a promising platform rather than a near-term platooning or autonomous system. This is one that's, I think, probably worth considering. It's currently being operated commercially in Texas, and this is a fully autonomous truck system. Currently, it's only operating on highways, but it's operating autonomously on routes between distribution centers. A truck, a bit like a Tesla car, that's full of sensors and it operates autonomously on these systems. And I think it's probably potential for forestry, but it will certainly won't be a near-term solution. And another thing that may help improve efficiency, and that is two-stage tracking. So rather than loading logs straight onto the truck to take to the mill, they're loaded onto off-highway log trucks that take them from the harvester to a secondary area where they can then load onto a road truck to go to the mill. And work's being done in New Zealand looking at that, and the claims are that it can reduce roading costs, environmental impacts, and the aim is to reduce the cost of transportation. So again, I think, have that conversation with the New Zealand FGR. This is a technology that could be rolled out straight away, and would fit into existing systems. Looking at nursery technologies, nursery automation improves productivity, consistency, and labour resilience. The industry identified robotic cutting collection and automated weed control as key priorities. Automation can reduce labour requirements and improve production consistency. Technologies include precision seeding, tray filling, conveyors, automated transport, etc. And automation can increase nursery capacity while reducing workforce and injury risks. Nursery technologies there, and you can see, so that's broken down into different parts of the nursery stage. So precision seed handling, automated tray filling, sensor-driven irrigation and fertigation, vision-based grading and culling, and internal transport automation of trays and plants. And there's many commercial offerings in this area, so I won't detail them here, but if you look at the report, it outlines the commercial companies that offer solutions in these areas. The technology areas that we sort of recommended as being of interest for the Australian forestry nurseries is, one of them is this TTA ISO Flex planter. And so this transplanting system has the ability to have different types of trays or ways that seedlings are produced fed into it, and then it can transplant it into different systems. So it's a very flexible way of taking seedlings and potting them on into different type situations. And this could again be a good way of transitioning from a labor intensive system to a automated system. Another tool that I think is of value, and I think is being used in similar ways in Australia, is a seedling grading prototype, where effectively a seedling is being assessed visually using cameras and an algorithm, and then is either being passed or failed, so that the seedling is passed and is put out ready for planting, or failed and has a different outcome there. So this is another project in conjunction with that FGR's working on, and they're currently carrying this out at a commercial tree nursery in New Zealand. So that will provide seedlings that are more uniform. So you'll have seedlings that go out in the field, that uniform characteristics, hopefully uniform growth characteristics, but that will also be of benefit for any autonomous planting systems in future, having that ability there. The LPOT system, which is a system out of the Netherlands, it's a commercial system. I'm not sure whether it's been currently used on forestry trees. Effectively, seedlings are grown in individual paper-based pots, and those paper-based pots that have air pruning carried out on them, so they don't outgrow their environment, but that paper-based pot can easily be handled through transplanting machines or autonomous planting machines in the field. So I think the L-pot system certainly could have potential, relatively high cost, but I think that sort of system will be the basis needed to allow automation of planting technologies. Here, one that was definitely discussed by the people I talked to in the Australian nursery industry was the ability to automatically transplant plants rather. So this is a automatic transplanting machine that can transplant plants from seedling trays into pots, similar to the flex planter I talked about at the start. So this could drastically reduce the labor requirement and improve speed of production in nurseries. This one here is called the cutting edge machine, and this automates the planting of cuttings by looking at the cutting coming through and orientating it and planting it according to the characteristics. It doesn't currently take the cuttings, but this potentially could enable much larger scale production of clonal material and uniform cutting placement and reduce labor requirement vastly. There were some machines that claim to take cuttings, but they're very much research type machines currently. So if we summarize the offerings from nursery automation improves productivity, consistency, and labor resilience. So as I said, there are already a lot of commercial machines out there that offer seed handling technology, planting, tray handling, etc. And if we look at those bottom 3 points there, these technologies can be adopted in modular way in nurseries, so you don't necessarily have to change the whole production system to a different way. These could be bought in as a tray filling machine or a transplanting machine. They could also offer a practical solution to labor shortages, because they replace a number of labor units there. But they also, by producing plants that have very uniform characteristics, uniform size container, and uniform growth pattern of the plant, that then allows future developments of autonomous planting out to have a better chance. Also point out this technology review that no doubt some of you have already been aware of. This is one that was carried out by FGR in New Zealand again, that provides a good background into the available nursery technologies and how they could be of value for pine production in New Zealand. It's well worth having a read of. Okay, remote controlled felling wedges. This is a pretty short, sweet area here. Effectively, a wedge is placed into a cut on a tree, and as you can see, there is a battery in the tool there. The operator stands at a distance, uses a remote control. The battery powers a wedge that forces that cut apart and gives the ability to control the felling in a way that reduces the risk for the human operator. Quite a very simple system, but yeah, quite good. There are 3 commercial machines in this area, and the discussion was that these may have a place in cleaning up after a fire, but they're certainly available. They're highly developed, and they are widely used. Okay, that's the end of the recommended technologies. A lot to take in there, I'm afraid. But if we get onto a summary now, a brief summary, there are some commercial providers of automated and robotic systems available now, planting, nurseries, operator assistance. There's a lot of research projects, prototypes, and patents, and it's a big area to keep aware of. I think it's certainly worth keeping abreast of what's the work being undertaken by New Zealand Forest Growers Research, which I understand that the industry in Australia does, but also Skogforsk in Scandinavia. They seem to be at the cutting edge of a lot of these technologies, and having a relationship with them, I think, would be very valuable. Oops. Okay, if we get onto the Australian Forestry Wiki page, one of I think the major outputs from this project was this Australian Forestry Wiki page, and hopefully some of you have had a look at it already. The idea was that those 300 plus technologies, tools that we identified would all be made available in a single web-based system rather than a single report, which would be unmanageable. So each of those tools and technologies has now been created into a page, and those pages are given a number of topic headings and links so that people can search for tools and technologies and identify them. And this approach follows best practices used by platforms such as Wikipedia, but also organizations like the Food and Agriculture Organization internationally. They use wiki pages, etc. The other good thing about this is that the wiki page system, the wiki system, can be updated on a rolling basis. So unlike a report, it doesn't immediately become obsolete when it's published. And you can see I've put the link down there, so if anybody wants to go and have a look at it, the link is available. One of my colleagues developed the interface here, so a very simple interface where we set up a front page that gives a bit of a background to what the wiki is, what the aim of the wiki is, and then multiple different ways to identify technologies here. Obviously, you'll see there's a search bar at the top, so if you know in particular of a tool or technology that you're interested, you can search there. Or down the side here, you can look at different areas of production and the industry, click on those, and get those lists of technologies brought up. And again, if you scroll down, there's pictures there, trying to make it as user-friendly and intuitive as possible, including a link to the full technology index, which probably most people won't look at because it's so long. So if we click on harvesting and extraction, you can then see that it brings up different subheadings under the harvest and extraction area, but also it puts up the recommended technologies that we recommended in the report at the top of that section, so people are guided towards looking at the technologies that we think are most appropriate. And if you click on one of those pages, you then go to the page that outlines the tool or technology, or in this case, program of work that's being carried out. And you can see here there's a number of tags. So if you click on one of these tags, it will then take you to other technologies that relate to that tag there. So I've clicked on operator assistance, and it brings up all these different web pages in the wiki that can be clicked on to give you more information on that. And so you can go through and look at hydrogen-powered aircraft to create digital twins. So yeah, we think that this could be the most valuable bit of this work, because it's captured everything we've found, but it's also provided the basis for an ongoing way of keeping up to date with new technologies there. It also has the ability for different people to log in and have different profiles. So in time, there could be an administrator or a lead user or something like that. It also has the ability to do analytics so that we can see how many people have been using it, where they've come from, etc., etc. So it's quite powerful. Okay. If we look at the project overall and look at some of the discussion points and some of the conclusions from the report, I think one of the key things is that automation is a journey. It's not a step. It's not a single step. It'll be a stepwise process to get to automation. It has to integrate with workflows, data, and decision making. The key barriers are skills, data capability, infrastructure, and local validation. And that came up time and time again, was how there would be tools and technologies that would be useful in Europe or North America, but without local case studies and local validation, there will be some resistance for them. Solutions must be reliable, user-friendly, and suited to Australian conditions, just reiterates that. And long-term impacts will come from practical integrated solutions aligned with forestry needs. So really what we're saying there is that there will be, it's unlikely to be a single technology that will drastically change the face of the industry, but there will be a number of stepwise transitions that fit into the industry, fit with the industry, and progress it over time. The successful forestry automation, and this is the same in primary industry agriculture, successful automation is less about technology availability and more about how it integrates into the system, how it's rolled out, and how it's supported. A staged system level approach offers the most practical pathway to adoption and long-term value. Capability development, local validation, and industry collaboration are critical to successful deployment. Technologies that are practical, adaptable, and integrate well into existing operations are most likely to succeed, as we said before. And as we also said before, is one of the challenges with technologies is that some of them can be such a big step to implement that for a single user, a single harvester, a single company to implement them will be difficult. So having a combined industry effort to bring these technologies into place may result in a much higher chance of them being used and providing value. Okay, we'll probably covered that. Right. Recommendations, go through those. Many forestry automation technologies are already proven and being adopted internationally. Some of the technologies that are more advanced, more technologically ready, are achieving widespread uptake. But as I said, there are a lot of them that are still in pilot stages, and we'll definitely see that there are a lot of technologies that promise a lot, but when you actually dig into them, they have very little, they've delivered very little. Successful adoption depends more on the system readiness than the technology availability. So how the system that they are going to be used in adapts or will adapt to fit the new technology, rather than a new technology being introduced and being orphaned in a system. Key barriers include integration, infrastructure skills, investment risk, and regulation. And something like regulation is obviously a critical one around things like UAVs, definitely a big issue here. We think that you should prioritize proven technologies, so technologies that are already proven overseas and as giving benefit. Those are the ones that are more likely to add value to the Australian industry. Adopt a staged pathway, so there where machineries and operator assistance and nursery technologies, all of those systems will help lead towards forest automation in time, because there will be more uniform plants, there'll be greater capture of data, etc., and greater ability to automate operations in the field. So it'll be a transition from very manual operations through more and more mechanization, with the end goal potentially being automation. Obviously, technologies need to be proven in Australian conditions. Strengthen connectivity, infrastructure, and data systems to enable advanced technologies. That's as simple as having cellular signal, which is still a bugbear in New Zealand agriculture, is having reliable cellular connections. Promote collaboration, knowledge sharing, and regulatory engagement. Again, the ability of a expensive technology to be taken up by one company is a much harder sell than if it's somehow the adoption of that technology can be shared across multiple users. Technologies will have to adapt to Australian species, terrain, climate, and operating conditions. And the two that I think are probably most critical there is how so many of these systems have been developed for conifers, and obviously a lot of Australian forests are eucalypt, so quite a different plant structure. And the other one that I suspect will be a challenge for a number of these systems is the heat and dust in Australia. So that's something that may not be considered by particularly Scandinavian producers. So it's something that will definitely need to be tested. And success requires alignment of technology, people, infrastructure, and regulation. Okay, factors for technology adoption. There are a number of factors there, and to a certain extent, these factors align with the points that I just discussed there. There needs to be awareness and understanding, evidence from Australian conditions. Yeah, so they've really covered those before, and you can have a look at these. I think one of the key things there is that the technology alone does not create the value. It has to have all the foundations in place to be able to offer the value in the industry. The biggest adoption challenges, I'm just raising my desk to try and get out of that sun, sorry. Key barriers identified: people and capability, is having people that are able to use these new technologies, the technology and the infrastructure to use them in the field, and the organizational readiness. And so these will be common adoption challenges across all technologies in different industries. So what's happened here? Sorry. Whoops. So recommended pathway for Australia: trial and validate technologies in Australia, invest in workforce skills training and digital literacy, strengthen connectivity data systems, promote industry-wide data sharing and benchmarking. So I think that one's absolutely critical if you're looking at things like digital twins, is the more data that is available, shared and integrated will help enable those sorts of tools. Prioritize integration with existing systems. Engage regulators early if autonomous machines, etc., are needed. Adopt technologies incrementally, and that will result in building confidence and capability over time. You have a look at that later. That's just talking about the technology infrastructure there. Implementing the findings of this report, that goes through each point, each area that we discussed and look at how these findings can be implemented, and also gives an outline of some of the factors that may impact the adoption of these technologies. Just to sort of touch on the communication plan, we've been working with FWPA, and we've produced a brief article that summarizes the findings of this project, and that will be published in the near future. We also propose that over time the Australian Forest Robotics Wiki will be maintained and updated.